Right now I'm just making a video for some challenging problems that we did on 6.2 because I saw some students yelling at me during the test yesterday telling me how hard it was. So let's have a review. These are some problems that we're going to review. The first one I wanted to talk about was number 23. Number 23 comes to us looking like this: negative 16 plus 4x to the fourth power. Now, this is our section on difference of squares. Okay? So, the question is this a difference of square? Well, we can move the numbers around. 4x to the fourth is positive and minus 16 is negative. And so when we look at it like that, yes, it is a difference of squares. So I'm going to rewrite it over here. 4x to the fourth minus 16. Okay? We're just rewriting it. Now, I had some students that were doing this. They take the root of this, and they got a 2x and a 2x, and then they take the root of this, and this is a 4 and a 4. One is positive, one is negative. Sorry, that's so messy, huh? Okay, one is positive, the other is negative. Well, if this is the answer you had for number 23, it's wrong. What's wrong with this answer? Yes?
You would need factor x to the fourth.
Oh, wait, sorry. Yes, okay. Besides that, I should have done this and this. Okay, you're right. It should have been that. But what's wrong with this answer? Let me put it, hold on, wait. Squared and squared. Okay, what's wrong with that answer?
Factor 2x to the second minus 4.
And how do I break that down?
It will be x, so x minus 2 to the quantity of...
Times the quantity.
Times the quantity of x plus 2.
Okay, this is not a difference of squares. This right here is not a difference of squares. Why? Because the 2 is not a perfect square. So that's not what's wrong. What's wrong, Adam?
You can divide 2 out of it.
Yeah, we forgot to GCF. Remember, the first step when we have a problem is to look for a GCF. Well, I missed my chance the first time. It doesn't mean I can't pull it out now. I'm going to pull out a 2, and then what's left here is an x, right? Let's call that my 2. I'm going to pull out a 2 out of that whole thing, and then I'm left with an x squared. Oops. X squared plus 2. Okay, and then I can factor out another 2 times 2, and we're left with an x squared minus 2. None of those can be broken down, but this can multiply to 4 times x squared plus 2 times x squared minus 2. Okay? Now, had you done what I've been advising, 4x to the fourth minus 16. Step 1, we factor out our GCF. Then I'm left with x to the fourth minus 4. 4 times x squared plus 2 times x squared minus 2. Do you understand? So I'm asking you to do your GCF like it's habitual the first time. Sometimes we don't have a GCF. But I certainly have one here when there's a 4 and a 16. 4 divides into both. Does that make sense, guys?
Yeah.
So if you gave me this answer, it would have been wrong. This is the answer. Fully factored. And there are no partial credits. Okay, so that was 23. The other problem I really wanted to work on, let's see, 31 was... Let's go back here. This is 31. Sorry, somebody wanted 31. And that was 81y to the 6 minus 25y squared. Who asked for 31? Okay. Do we have a GCF? Oh, yes, we do. We have a factor in common. Y to the second. And when I do that, I'm left with 81y to the fourth minus 25. So what I'm left with is a perfect square, and a minus sign. So it is a difference of squares. So I have y squared And now we're going to make the root of this is 9y squared. 9y squared. The root of this is 5, and 5, 1's a plus, and 1's minus. All right, so am I fully factored? Can I break down this? Is this a difference of squares? No, because 5's not a perfect square. So that's my final answer, 31. Okay, next one, 33. 33, who needed that? Also Jonah? Do you understand? Okay, so let's go on to, you had to GCF it. I lost my list. Okay, we're going to 37. Okay, 37 is 75, m to the 6th, n squared minus 147. Ooh, that's so ugly. Well, it would have to have, Gideon, I think you asked for this one. It has to have a GCF. What is the GCF? Okay, I'm going to check for divisibility. 5 goes into that, but it doesn't go into this. So now I'm going to try 3. Why? Because 7 plus 5 equals 12, and 12 is divisible by 3. 1 plus 4 plus 7 is 15. That's divisible. So 3 is going into both. I'm left with 25, m to the 6th, n squared minus
49.
Thank you. Is that right?
I was kind of guessing.
I don't know.
Yeah,
I thought you did it.
It's right. Yeah.
So it's 4, it's 12.
49.
Yeah. So it's 49. So now what I'm left with is a difference of squares. By the way, with these exponents, the only time you can break them down to a perfect square is if they're even exponents. Like if it were m to the 3rd, there's no quantity times itself that will equal m to the 3rd. Do you understand? M to the 1st times m to the 1st does not equal m to the 3rd. M to the 2nd times m to the 2nd equals m to the 4th. There's nothing times itself that will equal that odd number. So now I have 3. I'm going to break it down. The root of 25 is 5. The root of m to the 6th is m to the 3rd. The root of n squared is n. 5m cubed n. The root of 49 is 7. 1 is a plus, and 1 is a minus. Okay? We're recording. Thank you. Okay? Next one. Now I'm getting to the problems, B problems. Number 60, I'm going to start with 65, which is a fraction problem. So it's 18x squared, x cubed, times minus 8 over 25x. First of all, we always have to check for GCF. I know that there's a GCF of x, but I'm wondering, is there a number they have in common, 18 and 8 over 25? A hint. All you really have to do is look at the numerator. You don't really have to, let's say I want to see if 2 goes into both, okay? Let's try 2x. 2x divides into 18x to the 3rd. How many times? I'd be left with 9x what? Squared. Okay, that works. Now, when I have 8 over 25 and I divide it by 2, okay, do we divide fractions? No, we multiply by the reciprocal. Now, what I can do is cross cancel, and I'm left with a very pretty number, which is 4 over 25, which is a perfect square. I pulled the x out, right? You guys with me?
Yes.
So now I'm ready. I'm going to bring the 2x down, my GCF, and then what's left, I'm going to break down that difference of squares. What's the square root of 9?
3.
Okay, what's the square root of x squared?
X.
And what's the square root of 4?
2.
And what's the square root of 25?
5.
And one is a plus sign and the other is a minus sign. Okay? Questions? Yeah.
Could you multiply everything by 25 to get rid of it?
No, because it's not an equation. If it were an equation, we could do that. We could clear the fraction. But we can't do it with the expressions. Okay, that was number 65. I also saw somebody wanted 67. Do you still want to do 67?
No.
Okay, let's go on to a decimal. I want to try 68, which is 3 and 24/100ths, x squared minus 81. 0 and 81/100ths. Okay, this is number 68. I don't think it was your homework. Now, when you have something like this, you can just look at it like 324 x squared minus 81. Okay? So, first, you got to know, is 324 a perfect square?
Yes.
I asked you to go home and memorize. What is it? It's 18. So, it's 18. If I were just doing it without the decimals, x squared is x, 81 is 9, 1's a plus, 1's a minus. Okay, so when we're doing this, and I have that 18 times 18 gives me 324, I have one decimal digit 2. Where does it have to be where it's exactly the same so that I end up with 2 decimal digits? Yes.
1.8.
1 and 8/10. Good. So this really should be 1 and 8/10 x. And then the 9 times 9 equals 81. Again, we need the result to be this. So I still need 2 decimal digits. Where does it have to go when I'm multiplying it? Go
0.9.
0 and 9/10, right? So it's 0 and 9/10. One's plus and one's minus. Okay. Questions? All right. So that was our decimals. Another big one, a real challenger. I love this problem. And I think you guys are all strong enough to understand this. This is number 73. And then I had, should have done this. Okay. Is this a difference of squares?
No.
Absolutely it is. This is a perfect square. It's a binomial. And it's squared. That means 3a plus 4 times 3a plus 4. Yes, it's a perfect square. So when I do this, and 49 is a perfect square. So when I do this, actually, I'm going to do it like this. I'm going to make a little 3a plus 4 is the root of it, right? Oops, I don't really need those triple parentheses. And I probably should have done, the square one should have been on the outside and the, okay. And then over here, I'm doing, I really should be, 3a plus 4. Okay, the root of 49 is 7. One's going to be a positive and one's going to be a negative. Now, we can simplify within. 3a plus 4 plus 7 is 3a plus 11. Okay? Okay, let's do another. And then I can do this one is what? 3a. Uh-oh. Am I done? Why? Maxim? There's a 3 in this second binomial. They have a common factor in that binomial. You're not pulling from the other binomial. In this binomial, there's a 3 I can pull out. Okay, I like to put it here. Right? And then I have 3a plus 11. When I factored that 3 out, what's going to be left here? A. And when I factor a 3 here? Minus 1. Now, earlier today, I had a whole riot that we couldn't put the 3 here. Because that's going to be a different quantity if I multiply it here and then I take the result and multiply it here. But I'm going to remind you, if it's straight multiplication, and it is, It's multiply, 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 3 parentheses. It's no different. Can I will 2 times 3 times 4, is that equivalent to
24.
Is that equivalent to 4 times 2 times 3? Order doesn't matter when you're doing straight multiplication. This might make 6, then we multiply it by 4, and that makes 24. Here I have 8 multiplied by 3, it's 24. They might look different on the way, but the end result is the same. So the order in which you put it doesn't matter. I could have even written it like this. Right here, I could have rewritten it like 3a minus 3 times 3a plus 11, and then factored the 3, then I'm left with a minus 1 times 3a plus 11. So this and this is equivalent. Do you understand that?
Yeah.
Okay, questions? Yes.
Why do we not have to agree from the first binomial?
Because you would have to have, we can't take a piece of a binomial. There's no common factor in 3a plus 11.
It's like,
We're just factoring out of this binomial.
because they both have 3.
Yes, because 3a has a 3 and negative 3 has a 3 in that binomial. You factor by binomial. You can't take a piece of another one. That you would have to have common factors within the binomial. Okay, now, this is a guarantee. I will definitely put this on your test. X to the 16th minus 1. Something like this. Very similar to 75, which is y to the 8th minus 256. Put your hand down. I'm showing them. Okay, so I suggest writing it down. Is this a difference of squares? Is this a difference of squares? You're going to practice this tonight. Don't try and memorize it. Practice it. Okay, Lily. When I'm breaking down a difference of squares, what's the root of that? To the?
8.
Yep. And what's the root of 1? Good. And one's going to be a plus and the other's a minus. Okay? Can either of those be broken down more?
Yeah.
So I'm going to keep this one, x to the 8th plus 1, and then I have to break down this. Finnegan, what does it break down to? RJ?
X to the 4th, and then plus 1.
Times the quantity?
Quantity of x to the 4th minus 1.
Good. Okay, I'm going to keep it, break it down. Right? I'm always breaking down my difference of squares. X to the 8th plus 1, x to the 4th plus 1, and now I have x squared plus 1 times x squared minus 1. Okay? I'm going to keep it, x to the 8th plus 1, keep it, x to the 4th plus 1, keep it, x to the 2nd plus 1, and then we have to break down that last one, which is x plus 1 times x minus 1. And that, my friends, has to go in your answer column. So those were some tricky homework problems. This is expected that you know how to break that down. Questions? Yeah.
Why do we keep the x to the 8th in the first set?
Because it's a sum of squares and there's no quantity times itself. Look at the chart. The only kind of binomial that can be factored outside of GCF is a difference of squares. A sum of squares, there's no number. I'd break x to the 8th plus 1 down, but there's no number times itself that will equal that. A binomial times a binomial will give you a trinomial, not this. The only time a binomial times a binomial equals a binomial is with a difference of squares. Got it? Okay, questions? All right, that's a homework. Those were homework problems.